Now we have questions in this video, that is day 3 and combined loading, that is axial plus bending. So we have 2 questions. So now we will go with this. So we have first question. Just a minute. A hollow rectangular machinery pier 1.2 by 0.8 meter overall. The wall thickness B 0.15 meter, a vertical load 1000 kilonewton is transmitted in a vertical plane, bisecting 1.2 meter side at an eccentricity 0.1 meter from the axis of the section. Now I will solve actually this problem with kilonewton and meter, and next problem with Newton millimeter, so that you can understand, because these problems generally are solved with kilonewton and meter square. So now we will consider 1.2 by 0.8. So we have 1.2 by 0.8. So this we have 1.2 meter. And this is 0.8 meter. Now the wall thickness is given 0.15. I will use another color. So we have 0.15 from both sides. Means it will reduce 0.3. So we will get inner dimensions, that is equal to, so this inner we will get as 0.9 meter, and this inner we will get as 0.5 meters. Now bisecting 1.2 means we have is column load on this line. So we are in this fashion, and that is 0.1 meter. So I will consider 0.1 meter, and there I will show load. So we have 0.1 meter. So somewhere here. So this is 0.1 meter. And P load is given 1000 kilonewtons. So moment is about this axis. And therefore parallel to this axis, we have width, and perpendicular to this axis, we have depth. So we have Ixx, we have to find. So moment is about this xx. So parallel to this we have width, perpendicular to this we have depth. So now we will start with. So we have A equal to 1.2 into 0.8 minus 0.9 into 0.5. And if we solve this, we will get value of A, that is equal to 0.51 meter square. Now I, we have to find out B, we have now 1.2. D, we have 0.8 cube by 12 minus we have 0.9 into 0.5 cube by 12. And we will get value of I, that is equal to, I is 0.0418, 0.0418 meters square. Now Y, we have 0.4 meters, because we have this as depth. And this as width. So now we will find sigma A. We have P by A. We are finding in kilonewton meter square. So we have 1000 divided by area, we have 0.51. And from this, we will get value of sigma A 1960.78 kilonewton per meter square. If you have calculated Newton per mm square, so it will be 1.96 Newton per mm square. It's simple one. Because kilonewton becomes Newton 10 raised to 3, and meter square becomes millimeter square 10 raised to 6, and you will get this will be 1 upon 10 raised to 3. So divide 1960.78 by 1000, it comes 1.96. Sigma B, m by I into y. So m we have 0.1, that is E. So m is P into E. P is 1000. E is 0.1. Y we have 0.4. And I we have calculated 0.0418. I got this value sigma B 956.94. 956.94 kilonewton per meter square. And if we will find it in Newton per mm square, it will be 0.96. Now we have, let us, this will be A, we have B, C and D. Now load is on this side. So we have sigma A equal to sigma B, and that is equal to again sigma A plus sigma B. And we have 1960.78 plus 956.94, and we have this value 2917.72 kilonewton per meter square, or 2.92 Newton per mm square. And we have sigma C equal to sigma D, and we have this value sigma A minus sigma B, which will be 1960.78 minus 956.94, and it comes 1003.84 kilonewton per meter square, or 1 Newton per mm square. Now, if you have to plot it, then you will get value in this fashion. Both are in compression. If I will plot, so this is CA portion, and we have this value. At A, we have 2917. And then sigma A. So if you will plot it, then if you will draw both values, you have this will be sigma A, and plus if you will plot bending stress, then we have plus bending stress. At this, we have negative. At this, we have positive. And therefore, value will be added on this side and will be subtracted on this side. And therefore, we have this value equal to 2917.72, 2917.72, and 1003.84. 1003.84. And we have this value. So we have stress in this fashion. So this is C and this is A. So now we will switch over to the last problem of this. So we have a cast iron vertical pillar. Now this is most important problem. So we have 150 mm diameter. Now I will draw a little bit larger. Consider it as a circle. So we have this will be 150. Now they have mentioned load is acting at the center of this. Okay. So now the center of the hole. Now we have hole of 50 mm diameter. Now try to understand diameter is 50. So and center is 40 mm. So we have been somewhat like this. So 25 from here we have circle. So we have this as 50. Sorry, 40. And this diameter is 50. So load that is given at center. So I will draw load that is again 1000 kilonewton, which is at center. I am tying problems are different. So we have this as 1000. Now, as we have hole on this side, so automatically my CG will be shifted towards left of this axis. Left of this axis. So now we have to first find Y bar. Now we have moment now about this axis. So now area we will first find. So we have pi by 4 into 150 square minus pi by 4 into 50 square. And we will get this value of area that is equal to 15.71 into 10 raised to 3 millimeter square. Now find I, because we require these values. Pi by, now before I, we have to find Y bar. So we have Y bar that is equal to summation AY bar upon A. Now we are taking moment about this line. So I will say this will be my OO. So Y bar from O, we have area of whole circle pi by 4 into 150 square into centroid of this will be at center 75 from here. So into 75 minus pi by 4 into 50 square into its centroid. So 40 from here. So 35 from here because total we have 75 into 35 divided by area. Area we have calculated 15.71 into 10 raised to 3. And from this we will get value 80 millimeters. So I already mentioned it is on left side. So I will plot value that is axis, centroidal axis. So we have axis over here. And this value I have 80 millimeters. Now we will start to find value of I. So I we have now Ixx plus A into H square. Now Ixx we have pi by 64 ICG I will say, not XX actually, CG. Now pi by 64 into D to the power 4 plus area pi by 4 into 150 square into H. So what will be distance between the two centroidal axes of hole is 80 mm from top. And of this individual 155 is 75. So distance between the two, we have this distance, which is 5. So we have into 5 square. And we have to subtract of this whole minus. So we have pi by 64 into 50 to the power 4 plus area pi by 4 into 50 square. Now h. So we can have h of this is 35 from top, and whole section we have 80. So we require this distance. So 80 minus 35. So 80 minus 35, and it comes 45. So we have into 45 square, and then solve this. I got this value 21.01 into 10 raised to 6. Then we have to find sigma A. Sigma A is P by A. Now I am converting all in Newton and millimeters. So 1000 into 10 raised to 3. Area 15.71 into 10 raised to 3. And from this I got this value 63.65 Newton per mm square. Then we have sigma B, m by I into y. So now y we have two values. So I will put it as y only. So m we have 1000 into 10 raised to 3. What is value of E? So P is acting at 75 from O here, and central axis here we have. This is centroidal axis. I mention it as CC. So we have to take moment above CC. So we have this distance, this value, that is 5 millimeter only. So we have E 5 millimeters. Divided by value of I we have 21.01 into 10 raised to 6. And from this we will get it as 0.238 into y. Now I will mention it as y1. I will mention it as y2. So y1 we have 80 millimeter. Y1 80. And y2 we have 70. Total we have 150. Now we have sigma B1. So sigma B1 is equal to 0.238 into 80. We have this value 19.04 Newton per mm square. And sigma B2 0.238 into 70, and we have this value 16.66. Now we have one on left. So sigma 1 equal to sigma A, and sigma 2 equal to sigma A. Now where we have plus, where we have minus. So just see, we have load on right side, that is towards 1. So this we have considered as 1. And this we have considered as 2. So as it is on one side load, and therefore this first becomes plus and second becomes minus. So this is plus and this is minus. So sigma A plus sigma B and sigma A minus sigma B. Sigma A we have 63.65 plus 19.04. It comes 80.31 Newton per mm square. And second we have 63.65. This is same, minus 16.66. It comes 44 point. So just I will calculate 63.65 minus 16.66. It comes 47. 46.99. So 47 Newton per mm square. So likewise, we have these values, that is of stresses. So now we will stop here only. So this is your part of exercise 3. Now we will stop here. Thank you.